here's some code. I want you to refactor it to be easier to read.
You should make it dark.
Talk to your neighbor about it.
So I guess we
All right, what should we do here? What's a suggestion you might have?
Put the output position ++ at the very bottom outside of both the if and the else loop.
Okay, there's two cases here, and when you repeat the same code in both cases, it's guaranteed to execute either way. You can move it, so this can go out of here and move that. Okay, so that's one thing to do.
To me, it looks like we don't even need the if-else statement because in the top section of the if, we're passing, like we have our comparison equal to 0, and we're passing it into the init class button. Otherwise, we're passing.
What's the other possibility down here? What was that value if it's not 0?
Then it's 1.
Well, there's only 2 buttons, right? And so 0, 0, 1, 1. All this thing could collapse. Is there anything, sorry, before I sort of show that, is there anything else you want to say?
Only thing with that, since we're incrementing output position either way, isn't it going to go from 0 to 1 or from 1 to 2?
No, that's the location in the queue of moves, whereas the type of button instead of red, blue is 0, 1. And so, yeah, so it's not just, it's the easy sign, red, blue, red, blue, red, blue. Okay, so here's one possibility. Grab the button number 0 or 1, red or blue, emit that value in the emit, and then change the position, right? No if at all. And whether or not you like having button number or you want to just stick that expression in here, you know, I can kind of go 50-50 on that. You good?
Doesn't this doesn't handle errors if the button number isn't 0 or 1?
Yeah, right. I'm not sure the other one does either. It basically says if it was red, it's correct. If it's something unknown, it makes it blue, which is also kind of its own problem, right? Because it's if else. And so I'd say maybe dying fast in this case is better than the other one. You can also do the ++, you know, in place up here, or you can do it separate. What do you think about? What do you think about that? Or yeah.
I think this one is better because then if you add more buttons, you don't have to refactor that if statement to incorporate those buttons.
Yeah, so
return the value in that list if you go 0, 1, and 2, and 3.
when you see the structure, really opens it up, right? Like here, there's two cases, 0 or 1. If you wanted to add a green button, also you have to use like a switch statement or something, 0, 1, 2, and then it starts getting more and more and more and more. This one works for any number of buttons, right?
Do you even have to make the variable button number right there, or can you just like meter output?
No, I'm saying, whether you want to explain what that is or not, it's some name variable. You could. To be honest, this was more just I wanted to fit it all on separate line, make it fit on the slide. So I decided to put it like that. Who thinks it's better? Who likes having a named variable there? Just a couple of you. Who would like to rather have it in the expression instead? Just go for it, basically. And a whole bunch of you don't be fair one way or the other. Who likes having this at the end? A couple of you. Who would rather put it up here in this thing here? Fewer of you, but some of you. All right. Well, no, it's like our democracy, only 30 people. Yeah, I kind of, I don't know. I understand the urge for this, putting it in line. I kind of like having it say, this is doing this one thing, this is doing the next thing, keeping them separate. You have to kind of parse those lines pretty carefully to see all the plus pluses mixed in and what it's changing, and is it a pre-increment, post-increment. You know, again, it's not the worst thing in the world, but another line of code is the worst thing in the world. And if you wanted to keep your debugging print statements here, you could have said flash button, 0 or 1, use the number itself instead of red, blue, or something like that, and you still have some debugging. You don't have to do that because you refactored it. So the only thing I'd say is that there's still a lot of code I see where you should be seeing patterns, right? Hey, this is kind of like this one. Maybe I can do something with that. Just kind of take that extra breath and think about, can I get rid of some of these? This is the way you're kind of thinking it out. Oh, if it's the red button, let's do these things. Oh, if it's the blue button, let's do these things. At some point, you should realize was the same thing in both cases, right? And do something with it. Don't just keep writing. Ponder it a little bit. All right. See, I have an advantage. I'm a very slow typist, so I'm pondering things all the time. I have to wait for my fingers to kind of keep typing. If you're a fast typist, you're probably too fast. You should learn to, just type with 2 fingers and you can be a good programmer. I want to demo adding like another window to our Qt application. So let's do this. Window test. Okay. All right. So I have our usual main window.h, the form. If I run this thing, I have to try to hopefully I get my blank widget. And let's add a button. So push button, and we're going to say pop up something. Let's just say pop up. So we're going to go pop-up window when we click that, right? Right. What kind of thing needs to pop up? So I'm going to click that, and I want something to appear. What is that something that's going to appear here? Some kind of widget, right? And I want it to be a custom widget. I want it to be my own widget. So let's go back, and I'm going to add a new Qt designer form class. So these things are, the UIs are the designer forms, right? And I want a whole class associated with it. So create a designer form along with matching class, header, and source, and you can add to the form class from existing projects. Okay, so I'm going to choose that. I'm just going to do a widget. Probably has a real pop-up. I probably should do a dialog that has some sort of automatic close stuff. Qt has some support for that. I can pick some size, which is kind of curious. Maybe a little bigger. And I'm going to call it form. Sure, why not? Probably be more specific for yours, right? And hit done. Hey, come back. So notice in here now there is a second .ui file that I can drag widgets onto. There is a form.cpp and a form.h. All right, so in order to use this in my main window.h, I need to make an instance of one of these new widgets. Form pop-up. And it doesn't know about form, so I need to include form.h. And now I want to use this somehow, right? So now I have two widgets. One is like the parent, the driver widget, when it starts off, main window. And then there's this form hanging around, this form widget. That doesn't also have much going on here right now. So in my button, I want something to happen when I click this. So I'm going to make a signal attached to a slot. And that funny go to slot action they have when it's clicked and makes a slot for me. And in here, what do I want to do? I want the form to show. So there's different ways to do that. One way is to take my pop-up variable and say I want to show it. All right. Let's run it and see what happens here so far. Let's run, pop up. Oh, there's my form. All right, so that's pretty good. Now let's change the form. Add a push button. I am done. And I'm going to add a slot here. Clicked. And when I click that, I want to close the pop-up. Well, actually, I want to hide it. I'm sorry. So I run it. Pop up. Sure. I'm done. Yay. Pop up again. Yeah. I'm done. Good. Okay. So that's all there is to it. The main thing is you have to know enough to add in another one of these forms, and then attach these things by adding in the sort of sub-form into the main window, and then tell it to do things like show itself or close itself. Now that's not the only way to make those go. So if I did show and hide there, the other window, the main window, was still active. Like I could still go to it and click on it and do things. It's just that two were on the screen at the same time, right? If I wanted it to pop up like a dialog, instead of showing it, I want to exec it. So like, you know, in the main.cpp, it says at some point a.exec, and it goes off and sticks in that widget sort of forever until you quit the program. So exec basically says, make the pop-up be the only thing you can work with right now, and then when you're done with it, you close it instead of hide it. So close means I'm all done with this sort of this part of the process, and it goes back to the main. All right, so that's a small example. Now I will say, I'm not suggesting for your sprite editor you should have a bunch of things all hopping up all over the place. In fact, I've seen some projects that are just like, you hit run and like 12 overlapping windows all appear, and it's up to you to kind of storm around the screen and figure out what's going on, right? And I don't love it. So let's say, first of all, why might you want multiple widgets in your sprite editor? Let's just talk big picture architecture here for a second. So one possibility is you have a widget, and in there you just have a lot of stuff going on, right? Here's some buttons over here, here's some drawing thing, here's some other stuff. So one possibility is you basically just have one class with a bunch of stuff. Another possibility is what? What kind of stuff can you do here? Help organize this a little bit.
You put them in smaller widgets that are sized off, so they can sort of reorganize.
Okay, so what would you put into smaller widgets? Like what kind of thing, for example, would be a natural for a small?
Something that you don't want to have on the screen all the time, like a save menu.
Okay, so there are some menu things, but you might even want to have it on the screen all the time and still organize it into subclasses. Like what?
You might just have your preview pane that oscillates the sprite.
Yeah, so maybe we have some overall widget, and you're saying at some point there's like the preview pane that bounces back and forth between the different versions, and maybe that's its own widget, right? You've done some custom work on it. What else might be like a custom kind of widget?
Tool sidebar.
So yeah, there might be some tool thing, and you know, depends how many tools you want, right? There's like the pick tool, and maybe that's it, but maybe you have more, yeah. And then maybe you have some place to draw, right? So some sort of color thing. There's, Qt has some built-in colorable stuff that some people invent their own sometimes. Anyway, you have some subparts. If you break it into separate classes, it's going to be a lot easier for your team to work on these things, right? Otherwise, everyone keeps hitting that same main window.h and main window.cpp, and your Git is going crazy, and you're merging left and right. Whereas if you're all saying, hey, you are working on the toolbar, you can go off and work on the toolbar and commit stuff, and no one else is touching the toolbar, and your life is a lot easier, right? So you split it up into different classes, you're probably a lot better. Now these things are some sort of, eventually, something that probably inherits from QWidget or from something else, right? And so how do these get put into this larger widget? So here's this big widget, QMain window. How do they all get incorporated?
You're gonna have to use some sort of layout.
Okay, so they get drawn by maybe, instead of popping them up, right? Like, it'd be kind of a nightmare to have your main window that was just like, use toolbar, and you click on it, and the toolbar pops up for a minute, and you click it, and then it close, and then use drawing area, and that pops up, and instead you just put them in a layout, right? And then the other thing is, how does this class know about all these classes? So we have a Q main window, or main window, I guess I have Q main window, and it has these things inside it. How do we do that in a C++ sense? What's that?
Included all in the file.
Well, to use them in anything, you got to include them for sure, but that's not going to make anything happen right off the bat. You still need to. What's that?
Have a main controller that does that.
Controller, I think you're thinking about. I'm just thinking more basic. So there's a main window class, and once they have these things inside, you use these things. How does that happen? One way is inheritance. Hey, is a toolbar an example of a main window? Is it a kind of main window? Not really. So what's the other choice? Make an object. Is there a name for that in a class? Data, a composition of the data member, right? So we just list them in the main window class in the header file and say, I want these things in my class, and then you use them, and then you put them in a layout, and you tell your team to work on different parts of it, and everything's good. All right? We don't make one giant class. And some things might not even be sort of related to Qt stuff. Again, there might be like a frames. I don't know, it's like some internal data structure holding your images and so on. So you have to talk these things out, kind of make sure your team's on the same page. Otherwise, someone's going to just start attaching the main window all sorts of stuff, right? They're going to start throwing everything in that main window class. You got to say, no, we got to break it into pieces here so we can kind of organize it and work out. That's what I want you doing right now. Thinking about that with UML diagram, how to organize these kinds of things. A Qt is a huge system, and there's some subtleties to it that can bite you. So for example, operator equals and the copy constructor for some things like QImage and I think some other things actually are deliberately made to be shallow copies. So if you say QImage I equals some other image J. Now that I've been beating you over the head over and over, we must have rules for you, we must do deep copies, we must do this stuff. I'm going to say, hey, they actually make this a shallow copy. In other words, there's some QImage somewhere, and both these things are kind of referring to the same one at this point. They're both pointing underneath to the same internal data. Why are they doing that? Maybe they just didn't understand rule 3 and forgot to implement anything.
Images are pretty big, so it's inefficient to make copies.
Yeah, images are big, and they want to make sure you're not just kind of randomly making copies all over the place, because this is still a performance system kind of thing, right? So, anyway, they have their own, they actually do some reference counting, because this was all done before some things got added in C++ that allow this to happen natively. And so they do all sorts of little tricks to kind of make this efficient. But don't be surprised if you're passing images around. For example, when you think you made a deep copy, it's still a shallow copy. You have to somehow, there's a copy method that does a deep copy for you. So sometimes you might have to explicitly do that. It's deep copy here. And in general, Qt wants to manage sort of the resources for things. So you can build up your widgets right now. For example, main window, it has that optional parent constructor that says that its default to null pointer. We haven't really been using it because we don't have multiple widgets around. But typically you say, hey, this thing belongs to this thing when you construct it. You say, make this Q label with this as a parent. And then this thing actually owns the memory for this, and it will all delete itself properly when you're done. So Qt wants to once you put it in the Qt system, it wants to control it. Now, as a part of this, they don't let you actually make assignments between different Q objects. You can't say Q object 1 equals Q object 2, or you can't use a copy constructor on it. And we saw that, actually I saw that a little bit in the assignment game. Some people would kind of pass in a model, which is a Q object inherited thing, into the constructor for the main window, and it was just the compiler would say, I don't know how to copy this thing. And so they've actually done some specifics to make that not allowed. The reason you don't want to make that happen is because as soon as you start copying like this thing, does that mean that the copy of it has a deep copy of this, or it shares the memory? It gets kind of confusing as to who owns what. So they don't want you to sort of be able to make deep copies off on your own. So one question is, if I wanted to not let objects be copyable or assignable, how can you do that in C++? Right? It's not like you just you still have to work within the language. And for example, there's always a default copy constructor. You don't need your own copy constructor. And there's other things. So you actually have to work to make things not be copyable. So one idea is to make those two things, the copy constructor and assignment operator, private. All right? So for example, you might have in your header file, private, the copy constructor, and private, the operator equals. And then outside code name can't be making copies of these things. And it just can't happen. So that's one way. Now I'll say the readability of this is a little bit low because you kind of have to search through the class to realize that this has been done. And so there's other alternative ideas. One is to inherit from something that's not copyable. And that's something called a mix-in. Basically, mix-in is with inheritance, but you're not trying to create a parent-child relationship. You're trying to sort of just steal some capability from some other class. And this one looks a little bit like this. So you have a class no copy, and it also has a private copy constructor and operator equal. And I'm doing a private inheritance of this thing. It just means that this part of this object can't be copied, so you can't copy the whole object. The one advantage of this is that you're basically making it clear that, hey, this class is part of this no copy inheritance chain, and so it's pretty easy to see that there's a very deliberate intent here to make sure that it isn't copyable. So I think that's pretty readable. It's a bit more mysterious. Now, I guess this was, again, I don't really feel a big urge to ever make my copy constructor assignment operator not be allowed, but apparently it came up enough that C++ 11 added in the delete keyword for these. So you can say, you know how we had to think about equals default, how you can make a default one by just saying equals default. You could also say, I'm not allowed to have a copy constructor or assignment operator using this equals delete. And then those don't exist, there's no default, there's no custom one, and the compiler will say, hey, those have been deleted. So anyway, I'm not sure which Qt uses. It probably has its own unique way of doing it or something, but it is doing something like this to prevent you from copying QWidget and inherited objects. And again, it's not that I care that much, but I sort of appreciate sometimes seeing the tricks people sort of play with C++ to make certain kinds of behaviors happen. Like, I don't know, I never would have thought of making a private copy constructor, basically. So I appreciate it. All right. Now we're kind of marching right along here. Let's talk about adding libraries to your project in a Qt sense. So we've done that in make files. And if I have a library in a normal C++ project, what do I need to know to use that library? Come on, go back to the project everyone loves, libharu. What did you need to tell the makefile to use libharu?
And we have the path to it and the capital.
What was the first thing you said?
I have to have the path to it, so it's capital.
Okay, so you needed the library path. And then you needed the library name. And one more. The include path. All right. Now we don't have an explicit makefile here in Qt, so we need to work within their structure to make that happen. Now, let's just kind of review library stuff again. We have static libraries or archives, and they're .o files stuck together, some sort of table of contents into a typically .a for Linux Mac systems, and sometimes a .lib for Windows builds. And those get linked into the final executable. So once you make the executable, you don't have to know about the library anymore. Basically, you use it to build it, and then you have throw away the parts you don't use. There's also dynamic libraries, which we've not really talked about. And basically there, you load the library when you run the executable, right? So instead of when you're compiling the executable, you load it when it's running the executable, which is obviously a different time. And those are often in SO files, dylib files, or a combo of .lib and .dll, dynamic loaded library files, depending on what architecture you ran. So you compile using the .h, you link in a stub. Usually this thing is just, it's not really an implementation, but it's sort of a fake implementation. And then when it runs, it looks for these full libraries and tries to figure out how to run them. These are used a lot, these dynamic libraries, because one advantage is that, let's say you wanted to swap out the library, you can do an update and just sort of ship a new .so file, and you don't have to change the executable. It just, as long as the function calls match up and stuff. So it's more convenient to maintain things sometimes. And then there's header-only libraries, typically templated libraries, where you just include the .h, and find those, still need a -i to find them. Those are always the best. You find a header-only library, you're like, oh, this is going to be good.
Is the file extension the standard, or is there something that is actually looking for those specific extensions?
You must be looking for them somehow, because you just get the name of the library and it still figures out the .so on its own kind of thing. I was thinking it was pure convention, but there must be something knows about them. And of course, not very convention, because like every machine type has a different, every OS seems to have a different standard, right? There's also the issue that the library name sometimes depends on whether it's compiled in the debug mode or release mode. And sometimes they have little naming conventions, like the debug compiled library, so with a D here in the end. And if it's not, it's just a normal one. So I don't worry about it too much. Like if I'm using some image library, I heard debugging. I know it's like it's my own code that needs to be debugged. It's not the library. I mean, every once in a while the library has some problem, but it's really hardly any reason to kind of, step through the library code and see what's going on, because it's been battle tested and it's probably in pretty good shape. So I usually don't even bother looking for a debug version of these libraries and trying to incorporate, but sometimes it's helpful. Sometimes they're also in separate debug or release folders, and you have to say which one, and it's the same name but in different folders, and then that's also confusing. And then, you should be aware, in Qt you can decide whether you're compiling yours as a release or debug, and that gives you different information as you're running it. So there's a lot of these like subtleties as, what kind of library you're including, and what kind of version are you looking for. It gets a little, you have to kind of pay attention to what's going on. To use a dynamic library, the environment you run the executable in has to know about where that library is. And unfortunately, it seems to vary by operating system as well. So in Windows, there's a path variable And sometimes, like in the control panel, you go and say set system in variables, you have to type some weird strings into it and it figures it out. Macs, to be honest, it seems like I've been changing stuff around. There's this RPath thing. Sometimes it's kind of built into the executable itself. You can edit there. And then Linux has this variable load library path. You add path names to, and when you run it, it looks in those places for dynamic libraries. So I would say that's kind of error prone and a little tricky. The easiest thing is if you put the dynamic library in the same folder as executable, it'll look worth there and use it. So if you just package it all together, you can kind of solve a lot of problems just by putting it in the same spot. That's not like the pro way of doing it, you know. But if you're having trouble, that's a good fallback to see if you get it working. So you just take that .dll or .so, put it in the same build folder where the executable is, and it should be able to find it there. All right, let's add a library to a Qt project. So let's collapse that down. And here, make that the active project. I have add haru-lib as a project. What do you think I'm going to try to do here? I'm going to add haru-lib. The problem is, okay, now I've got like 400 versions of haru-lib all over my directories, and it's going to be playing this, picking one out before class, and now I already forgot where I put it, you know. So, okay, so I've got a main.cpp, and it doesn't know about haru-lib. It's confused. Where's the header file? What is this type, right? So I need to use the add the haru-lib to this project. All right. And kind of like, so I go to add library into the project here. There's a little wizard to help you. So instead of having to figure out what goes in capital L, what goes in capital I, and all that stuff, you just have to kind of poke through some stuff. All right, there's 4 choices here: internal library, external library, system package. For the most part, you know, it's a library you download from somewhere. It's an external library. Eventually, I might want to put it in your build path, but I think for now, let's stick with external library. You have to say what platforms you're going to provide this library for. So remember, Qt has a big focus on being built for multiple architectures at the same time, and we haven't really exploited that at all. In fact, it's a little scary. So for the most part, you're going to just pick one option here. If you're on a team and you're determined to work in some heterogeneous machine environment, with like Mac and Windows, for example, and not just being on the virtual machine, you should probably do something like this and tell it where both versions of the library are. One compiled for Windows and one compiled for Mac OS X, because they don't work to the same machine. And notice I pick Windows, you can say like the library is inside some subfolder, or it has a D suffix for debug version, it has all those little sort of quirks that they try to do with Windows builds. All right, so like I said, I just want the Mac one, and here it's going to say what kind of naming scheme I want, .lib, .so, .dll, and so on. I'm going to pick Mac OS, and I got to go find the library. Hit choose, and hey, I'm in some libharu folder already. Yay! This is an older libharu that doesn't have a lib subfolder, and yeah, okay, so I don't know why that was grayed out. Choose again. That's what I picked right there. Okay, fine, it shows up. So lib.hbfs.a. I want the .a file here. I already picked it. I don't know if I should cancel this. Let's see. Okay. It's going to assume that there is header stuff in that same folder, basically. That's not true for libharu, so I have to go choose that explicitly. So I'm going to go up a level. Hello, everything's very slow for some reason. Okay. Libharu, and I pick the come on, do something. Click twice, not good. Click 3 times. Okay. I picked the include folder, right? Not the include file, but the include folder. The path becomes the include. It's two different things. Here I'm picking the actual library file. So it goes and figures out what that .a is, and then it figures out what the rest of the path was to get to that .a. So it has both the dash capital L and the lowercase l all from that one piece of information. The include path is just a folder where the header file is, and then again I'm saying on the Mac, I say continue, and it says, hey, I'm going to modify your .profile with some stuff. So sure, sit down, and if we look, it's added for when I'm running on a Mac, and if it's Windows, it says something like Wind or Windows, I don't remember now, Linux exactly. And so it says add to libraries, this -L flag, hey, well, that looks familiar, and the dash lowercase l with the name over here. So it does the same thing we did, same syntax, you know what that means now, that's good. Include path, it doesn't include -I for some reason, but it does turn this eventually into a -I. And because I'm doing this on a Mac, I had to explicitly say I want that compression folder with Z. So I'm going to add that in by hand. So I can do that, right? I don't know where that is in my system, it's somewhere. But so I save it, and wait for it to parse, and go back here. Notice now it knows where the .h file is, and it knows where these things are. So I basically successfully added that to the project. If I run it, runs pretty much. It's a good output. There. Very good. I thought it would have a -I stuff in here somewhere. If I go to my build folder for this, it made a PDF. So it produced, when I run that test program, it makes a PDF with the same name as the executable. I made it here. And now you can relive your happy memories. We did it in Qt, right? Right, but the main thing is, you go through the wizard and it adds the stuff for you. And then once you get a little comfortable with it, sometimes, let's say you had 3 libraries. It's going to make a whole chunk like this for each library. And you really just want to sometimes just add on the end here, -L, something for the new library name or something. Just go hand edit the .profile. Don't let it just add line after line of hard to read stuff. Just keep it under control. Because you know what's going on in these things. All right, questions about that? Now, for the sprite editor, some of these things you might be including might be single files. You might want to just add them in as CPP files and just add them to the project because it's building along with it. But if you find something that has a .a or some other kind of file, you can use this approach to add it to the project. All right. All right, we still have our quiz to do. And it's a short quiz, multiple choice. So I'm going to say 305. Let's back up the test. So come on before that. Until then, who here, if you don't have a team, come up here. This makes a team, right? If you do have a team, meet with your team and start talking. But don't disappear because we got to still take the quiz. So if you don't have a team, come up here and figure it out. Put it together.